In this lesson, we are going to look through 3 experimental designs. So let's illustrate that with one scenario. It says EKHS has decided to offer an SAT prep class again this year. It will be offered in 2 different formats, online or classroom teacher. The counselors want to know which teaching method will yield higher SAT scores, so they've allowed us to set up an experiment. 50 students have signed up to take some form of the SAT prep class, and there are 20 seniors and juniors. So let's outline a completely randomized design. So we begin with 50 students. And what we're going to do is we are going to randomly assign them to 2 groups. And as I randomly assign them, I would split them evenly into groups of 25 each. So it's important that I'm stating that right here is where I'm doing this random assignment. And that's where, if it were an AP question, you would go through and talk about, you would number your students from 1 to 50. You would generate 25 unique numbers, ignoring repeats, into group 1. The remaining 25 numbers who correspond to the 25 students would go to group 2. From here, you would assign your treatments. So treatment 1, I'm going to call that the online class. And treatment 2 has a classroom teacher. So after I run this experiment, well then I've got to do some comparison to see how effective is this. So what am I going to do? I'm going to compare the SAT scores. Report different statistics to compare the effectiveness of the 2 treatments. Let's continue this scenario. The counselors at EKHS hypothesized that the online versus classroom results could be greatly affected by the grade level of students that were put into each treatment group. They know that seniors generally score better on the SAT than juniors. How could we adjust our experiment to ensure that there is an even split of seniors and juniors in each class? Draw an outline of the experiment with your modifications. So what we are going to do this time is known as a randomized block design. And what blocking does, it ensures at the beginning of the experiment that the units within each block are similar to each other with respect to that blocking variable. Okay, so if we block by the juniors versus seniors, so their grade level. The purpose of doing this is so that it helps to separate natural variability from any differences that are due to the blocking variable. So we always want to block by the variable that we think could impact the experiment the most. So the first thing I'm going to do here is take my 50 students and I'm going to block them. Right, so I'm going to split them into my 20 juniors, and I've got 30 seniors. All right, so that's clearly not where I do the random assignment. But from here, I am going to split each block into 2 groups. Okay, and this is where I'm going to do the random assignment. So I would describe that where I'm numbering the juniors 1 through 20, and I generate unique numbers, ignoring repeats. The first 10 numbers that are generated would go to treatment 1. I would generate random numbers for my seniors as well, split these into 2 groups. So I'll just call this group 1, and this would have 15 students, and my group 2 is going to have 15 students. And from here, they each get a treatment. So my group 1s are going to get treatment 1. Group 2 is going to get treatment 2. Okay, so after I have them grouped and treatments random assigned, I am going to compare, again, the SAT scores Finally, continuing the same scenario, the counselors are now worried that a student's GPA is certainly going to affect their SAT score. Let's look only at the juniors. We want to be sure that the different GPAs are being evenly distributed into the two treatment groups. How could we be sure that the GPAs are evenly distributed? So we're going to create a matched pairs design, which is actually a special type of blocking. And we're only looking at the juniors for this one. So again, beginning with 30 juniors. And what we're doing is, in a matched pair, just think of these words here. We need a pair, okay? So we need a pair of subjects that are very much identical, okay? So ultimately think like if you had identical twins. You could apply one treatment to one and one treatment to the other, and so many things about these identical twins would be the same that you could be, it would give you a really good comparison. Sorry for the PA system interrupting that. Okay, so what I'm going to do is I'm going to create pairs that are very, very similar. And how am I going to do that? Well, if I took my top 2 GPAs, maybe they're really, really close, and then I take my next 2 GPAs, and so on and so on and so on, all the way down to my lowest 2 GPAs. So I have 2 subjects in each of these with GPAs that are very, very similar. And then from here, I'm going to randomly assign my 2 treatments. And I'm just going to, keep doing this all the way down to treatment 1, treatment 2, till I have all of my pairs split into 2. I do again want to indicate that right here is where I'm doing my random assignment. And then I'm going to take all of these results and I'm going to compare the effectiveness by comparing the SAT scores. Let's examine some of the big ideas. So a block is a group of experimental units that are known to be similar. So with a randomized block design, what we do is we separate our subjects into these blocks, the ones that are known to be similar, and then we randomly assign them to groups. A benefit of blocking is that it allows us to account for the variation in your response that is due to the blocking variable. So therefore, it's easier to see if one treatment is more effective than another. And then that brings me to a matched pair design. So this is an experiment that is used to compare 2 treatments using blocks of size 2. So it's a type of blocking. 2 very similar experimental units are paired and then randomly assigned to a treatment. And finally, quick shout out to StatsMedic for sharing their resources and examples.